if you want a 99% confidence interval, then that means you want 99% to be in the center of a distribution that you're talking about. Okay, so here's an approximately normally distributed variable. A 99% confidence interval means you want 99% chance that repeated sampling will mean that the population mean or parameter, whatever you're trying to investigate, is in between these two lower bounds and upper bounds that you're going to calculate. That leaves 0.5% for the tails, or in other words, 0.005 over here for the left tail, and another 0.5% over here for the right tail to add up to 100%. Okay, so if we want a 99% confidence interval in my table, I'm going to be using this 0.005 to help me. Or actually, sorry, this is a table that has a two-tail probability. You don't even have to use all that. You want 99% confidence interval, so you want 0.01 in the tails. See how both of them are stacked on top of each other because they both mean the same thing. And then what did they say? The degrees of freedom is 29. So if we go down to the table, we're using this column. Degrees of freedom 29 right here, so this is 2.756. 2.756, but they want us to round to 2 decimal places. There we are. And 98% confidence interval, that means I want 2% for my tails, or another. I want 2% for both tails. So the two-tailed probability, 2% in the tails. In other words, 1% in the left, 1% in the right. In this one, they want 78 for degrees of freedom, so we're probably going to have to go up. So here's 75. You'd always want to increase your confidence interval. Well, actually, sorry. If you increase, let me think about that. They don't have 78 is the problem for degrees of freedom on the right. So for this next one, 98% confidence interval, it means they want 2% in the tails. So if you follow the two-tail probability down here, 78 isn't an option. So I think you'll want to go with whichever one's closest. But in reality, like you can get the exact value for 78 degrees of freedom with technology. So T-distribution calculator is what I typed into Google here. Let's go with this one. We want 78 for degrees of freedom. The probability is, okay, so this is that x is less than or equal to your value. So I would want to use 0.99. That will give me 1% for the right tail. Okay, so you could use a different calculator, one that lets you use 2, but I got 2.38 when it rounds. Oh, I forgot which one I had. So 2.38, which is what we would have got if we used the closer one. But technology, I mean, calculus is really what's going on behind the scenes of that formula, but technology can help us. Like that one, I had to use knowledge about, like, remember we said the left tail has 1%, the right tail will have 1% if you want 98% in the center. But you could even go look for another one. There's probably a two-tailed one around here. That's pretty confusing notation for students. Oh, no, I don't want that. T-value calculator. Yeah, this one says two-tail. So if you wanted to, it's not a super fun. These ads, 78 for degrees of freedom. Okay, so the p-value, that's actually not exactly what we're doing here, but we want 0.02. That's like the area in the tails. So we have find. I clicked on an ad. So same thing, 2.38 is what we get from